So we're going to deal with covalent compounds again and go through the naming process for it. So if we were to take a compound created from atoms of phosphorus and chlorine, knowing the periodic table, phosphorus has 5 valence electrons, chlorine has 7. If we make a compound out of these two, we will end up making a compound that has 3 chlorine atoms and 1 phosphorus atom, together 26 valence electrons. This fulfills the octet for phosphorus. Now this is based off of the octet rule, where phosphorus itself only has 8 electrons around its center. Chlorine each only has 8 electrons around its center. But where it can get confusing sometimes is that phosphorus, not being in the second row of the periodic table and being in the third row, actually can have more electrons around it than just the 8. So as it turns out, not only can you have PCl3 as in the molecule that we created, but you can also have PCl5, and this is a compound that exists. So to know the difference between these, the naming has to actually incorporate all the atoms that are involved. So in the case of the first compound, if we were to name this atom, we would go through and call it phosphorus, but we would count up the atoms and we would use the word tri for 3. So instead of saying phosphorus 3 chloride, we're going to say phosphorus trichloride. And that tells us that there's 3 chlorine atoms attached to a phosphorus. Same thing with the next molecule. We go through and we also say that it's phosphorus, but instead of 3, we have 5, which we're going to call penta. So we have phosphorus pentachloride. So this is telling us that we've got the 5 chlorine atoms attached to 1 phosphorus atom. So we can see the importance of the naming when it comes to a series of compounds involving nitrogen and oxygen. Now all of these compounds actually exist in some sort of form, but we need a logical approach to be able to name each one of them. So for the first name, we would put in nitrogen, and since there's only 1 oxygen, it's oxide. Now we don't have to say that there's 1 nitrogen and 1 oxygen, but we could indicate that if we needed to. We could say it's mononitrogen monoxide, and that is a proper way of saying it, but it's not necessary. For the second molecule, we know that we've got 1 nitrogen and we've got 2 oxides, so we're going to call that dioxide. Now people might be familiar with this molecule, and we know this as carbon dioxide. It's what we breathe out after our process of respiration in our body. So on the third compound, in this case we do have 2 nitrogens, and we do have to indicate that, so it would be a dinitrogen oxide or monoxide, whichever you want it. You don't have to write it. On the fourth compound, this one, we have dinitrogen tetroxide, indicating that there's 4 oxygens, and finally we have a dinitrogen pentoxide, indicating that I've got 2 nitrogens and I've got 5 oxygens combined together.